So in this video we're going to go over tries, and if you don't know what a trie is, think of it like a tree of characters. So tries are really good at storing things like words or strings in general and making dictionaries out of these words. So we're going to draw a trie right now. So let's say you wanted to add the word try. So first you'd have a node that holds t, and then one of its children would be an R because that's the next character in the word try. And then the next character, the child of R, could be I. And then it would have another node that it connects to that would be E. I'm drawing with my mouse here, as you can tell. So you have this, this picture doesn't really help, but let's say you wanted to add the other spelling of the word try, T-R-Y. So you would come down the tree, you say, okay, I have a T. Cool. Comes down and it says, okay, I have an R. Well, R doesn't have a Y, so it's going to go ahead and add a new, basically a new sub-try, and the character for that sub-try is going to be a Y. So now you have the word try, and you have the other version of try. So tries are really good at doing things like these, and they're actually really cool. So let's go ahead and program our try class. So now that we're in our text editor, go ahead and import java.util.asterisk and name your class, public class. I'm just going to call this try practice. You can call it whatever you want. You could call it try, but we are going to be making instances of these, so I wouldn't make them too long. And so tries hold, their nodes are characters. So we're going to say char c, and then the children for the try is just an array of possible characters. So it's an array of tries. It's not an array of characters, it's an array of tries which hold arrays of tries, and so on and so forth. So try array, and we'll call this children. So this is the children of a try node. And then we're also going to have Boolean word. Now we're going to have this, actually let's just show it in a picture why we're going to have this word Boolean. Let's say we have our try, and we want okay, so this is a try, 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 this try has one child, this try has two children, this try has one child, so, and this try has no children. So basically what happens is at the end of each word, that Boolean word is going to be set to true. That way, whenever you hit that node, you know that it's an actual word. So it would go try, and word would equal true right here. And the same for the end of the other spelling of try. Sorry, I'm drawing with my trackpad. So the same would be here too. And that way, whenever you're going to collect all of the words, like in a dictionary, if you have this dictionary full of words and you wanted to know all of the words in this try, you could just go down and hit every marker and then collect the rest of the letters from then on up. So we'll actually implement that in a little bit. But now you understand why we have the Boolean word. It's to know whenever we've hit the end of a word. So we wouldn't have word equal true right here, and we wouldn't have it equal true right here because these aren't words, but we might have it, actually no, I don't think that's a word. So we wouldn't have it here either, but we would have it here, and we'd have it here because this marks the end of a word. Disregard this check mark. But yeah, so let's go ahead and implement our try class. Back in our text editor, what we want to do is create our constructor. So public try practice. This doesn't take any arguments or parameters. So what we're going to do is we're going to set c equal to 0, our character. And then what we want to do is initialize our children as just an empty array of 26 tries. So this.children equals new try of 26 more tries. So what we're doing is we're saying our children is an array, like our children trie is a trie array that holds 26 tries. So basically think of it as a tree, and these are 26 subtrees. And we have 26 subtrees because there's 26 letters. Now you could get into the case with uppercase letters and lowercase letters and numbers and such, but right now we're just going to do lowercase letters. So we're creating a new trie that could store from A to Z in terms of lowercase letters. And then what we want to do is set word equal to false, because an empty string isn't a word in this dictionary. So now let's do our add function. So public void add, we're not returning anything, and we want to add string s. Now you can call this whatever you want. I'm just going to call it s because it's short. And so this, since a trie is built up by subtries, that means that it's going to be recursive, and a lot of trees are recursive, so it actually helps you understand recursion a little bit more by understanding how these trees work. So a core fundamental aspect of recursion is having a base case, and our base case is that we have an empty string, because once we've hit an empty string, that means there's no children there, and we've hit our base case. So if s.is empty, so if our string is empty, now you could say if s.length equals 0, does practically the same thing. So if s is empty, we want to set this.word equals true, because this means that we've hit the end of a word, because if there's no more characters to go through, then it must be the end of a word, otherwise it wouldn't be the end, there would be more characters to follow. And then we're gonna just write return to in the function. And then what we want to do is have a couple temporary variables, so we'll call this char letter equals s.char at 0. So we're taking the first character in the string and we're looking for that, and we're storing that in this letter variable. So next what we want to do is int index equals, now this is going to be kind of weird, but it's going to be letter minus a. So what we're doing, so A has the index of 97, or the value of 97. And our array goes from 0 to 25. So we have to have some way to convert this back to where A would be the 0th index, B would be the the first index, or index 1, and so on. So what we're doing is we're saying the letter minus that difference in value. So let's say we had B. Well, B would equal 98. So we'd have 98 minus 97, which means B would be at the index 1 in this array, which is correct because it's the second letter in our alphabet for this situation. Hopefully that makes sense, but if not, it should make sense sooner on. So our next task is to create an if statement, and what we want to do is check if there's anything at this index in the children array. So basically if this is null, then we know there's nothing there, there wasn't a word added, and what we want to do is put a new trie there because it's null, a trie hasn't been added. So this.children at that index equals new trie. And now what we want to do is add the string there. So we created that new trie, and now we're going to add the rest of the string. So this.children at that index, and then we're going to recursively call the add function again, and we're going to do s.substring1. So basically what we're doing is we added this character, and now we're going to add the rest of the string, and it's going to keep going until the string is empty, because we're substringing at index 1, so it's one by one it's getting one character shorter, and eventually it's going to be an empty string, and when it does, it's going to say that that's a new word, and it's going to quit the function. So that's how the add function works. Now let's do public boolean is word. So what we want to do is we want to take in some string s, and we want to check to see if it's in our dictionary or in our trie. So basically the way this works, we need our base case again because it's basically like the add function, except we're not adding anything. We're just trying to see if it's there. So if s dot is empty, so if we hit an empty string, then what we want to do is return this dot word. So this seems kind of weird at first, but since a trie is comprised of just a bunch of other subtries, whenever we get to an empty string, that means whatever character we're at, well, that's the last character in the word. So if that isn't the trie that holds the end of our word, so if it's not the actual word and we can't go any further, then obviously our word isn't there. It's like getting wrong directions. Like you hit a dead end, you can't go any further because that's the end of the word. So we're going to return whether or not word is true at that index or at that node. And if it's not true, it'll return false, obviously, and if it is, true. So now we have to traverse through there. So like the add function, what we need to do is keep track of the index. So basically what we need to do is have an index, or int index equals s.char at 0, like last time. But actually, this is a slight modification. We don't actually need this char letter. It just makes things easier. You could say s.char at 0 minus a. You don't have to store it in this variable, but I guess we can go ahead and do that. So char letter equals s.char at 0. And now we can just do letter minus a right here for readability purposes. So now what we want to do is check if that index is null. So we want to check if there's a trie as that child. So if this dot children at that index equals null, then obviously we're going to return false. Because if we're looking for a word and then the character that we're supposed to go through isn't even there, then we know that the word's not there because the trie would have that character if it was. And now if this doesn't happen, so if it's not null, what we want to do is return this dot children at that index, and then we want to call is word on that. So this is the recursive call. It's kind of like right here. And then s.substring 1. So it basically works the same way this does, except we're not actually adding anything, we're just looking for it. So now what if we want to collect all of the words in this trie? And we'll do this in part 2 of the tutorial because time's kind of running out.